I think the like 4 or 5 people not here might want to record it.
Okay, yeah, and see how it goes. So like I said, chapter 9 is called pointers. And when you get to 162, for a lot of you that are going there, the idea of a struct combined with pointers is going to be a big part of the course. And just about every semester when I'm in 162, we end up going back to chapter 9 to do a quick review of what's going on with all these pointers and so on. To get started, you typed in a whole lot of code listings, right? And the first one you typed in, I'm going to go to my other camera. All of a sudden, what became really important was the ampersand. And let's see, I need to change my view so I can see it. Speaker view, double click on me and I can see it. And some people are going to tell me that's a treble clef. Some people are going to tell me it's an ampersand. But when I start using the ampersand, it's an operator like the plus sign, the subtract sign. It's just one more operator that we have available. What does the operator ampersand do?
It indicates something is a reference.
Okay, you're right. Up to this point, we made it as a reference variable. A couple chapters ago, we started throwing this in our prototypes, and then in our function heading, we put it, and it was like, great, we're actually just passing the blank over to the function so that the value can change, but the blank doesn't change. Fill in the blank.
Memory address.
Yeah, the address, right? It's the memory address. And any primitive data type I have, the ampersand is going to allow me to get to that memory address. So if you looked at code listing 9.1, you saw we had something like X was 25, and then we did, we decided to print out ampersand X, and when it did, it gave some sort of memory location. In this case, if you have the book out, you see it gave you 0x8 FO5, something crazy. But this guy right here is going to allow me to get the memory address of that thing called an X. Okay, so the next thing we're going to do is we're going to talk about a pointer, and by definition, a pointer is a way to store. It's a variable we can create that's a way to store the memory address. Okay, and it's called a pointer, and we're going to use the word pointer a lot as we go through. In the declaration of a pointer, we're looking at something that, and again, I'm going to keep going with code listings. I'm going to look at code listing 9.2, and I see int asterisk pointer equals null pointer. Now, any of you have any trouble when you type this line in? Victor Ricci is in the house. Good.
Yes.
So when you type this line in, and he says hello, in asterisk pointer, I'm creating a pointer. This guy is going to point to a memory location of size 4 bytes where an int is stored. So I need to know what type of pointer this is so I know how much memory it's pointing to. But my question was, did you have any trouble with this part? And I got a yes.
Yes.
Okay. Depending on what version of Dev C++, you may have to put something else in here. What's another option that you had to put in to get it to work? Nobody got it to work?
I think the book said initialize it to 0. Mine, that was right. Yeah, null or 0.
Yeah, it's going to be one of those 3. Okay, remember 0 is the ultimate 0. It's false. It's a whole bunch of things. It's null is what it comes down to. So when I get ready to initialize a pointer, I'm going to say I want to make it a pointer. I want it to be of this type. And in our current version of Dev C++, most of you have to initialize it to capital NULL. Some of you are still null pointer, so on and so on. Questions? Now, another way to initialize it is int asterisk pointer, where the asterisk, instead of beside the pointer, is over here by the int. Let's not do that. this is going to be the answer to the test question that you're going to have. What way did we initialize a pointer in class? Even though this one's valid, this is the answer I'm looking for. Okay, so in code listing 9.3, we start to actually use this pointer. We do it in 9.2 as well. And we say pointer gets the address of X. Pointer, pointer. When I declare it, I put this in. Am I missing something on the chat? I see it's blowing up. Everybody's okay though?
It's just Alan asking if you can post a higher quality image of the Dan sort from last class.
Oh, okay. I'm sorry. I thought it might be something with now. I wanted to make sure. If you have questions now, ask them. But that's fine. You can keep working in the chat. Just let me know if I need something. All right.
And Conrad's here now too.
Okay. Sounds good. Thank you. Conrad's here. Victor Ricci's here. Noah, Mark, and Matthew. Any of you here? Okay. Somebody's here. No, those three are still missing. Thank you. All right. So first thing I have was the ampersand. It's going to use to give me the memory address. I have a pointer. A pointer, what did we say it's going to do? Holds a memory address. We're going to declare it. Int asterisk pointer. Is this allowed? Yes, but let's not use it. I don't want any confusion. Okay. Int asterisk pointer. If we want to initialize it, we send it to null in all capitals, 0, or for some of you, null pointer may work. All right. Let's look at an example. Pointer equals ampersand X. Pointer now holds the address of X because pointer's jobs are to hold the address. Now, if I did something along the lines of this, X equals 25, and all of a sudden I'd say something along the lines of pointer equals the address of X, what does asterisk pointer now give me?
The value of X.
The value of X. So this guy right here actually is the same as X from up above. Okay. What is it called when I do the asterisk pointer? It has a name. Anybody catch that when you were reading?
Dereferencing.
Dereferencing. Good. Dereferencing. So I want to dereference it. Okay. This guy right here is called something going on crazy on my machine. This guy here is actually called the indirectional operator. Okay. So we have two new operators now coming into play today. Questions? All right, in program 9.3, code listing 9.3, we create 3 variables, X, Y, and Z. We give them values, and we say things like pointer equals the address of X, and then we go something along the lines of asterisk pointer, which means that value at X, I can take it and, set it to 75 if I wanted to. I could take asterisk pointer and do plus equals 100. So then I'm going to add 100 to that. That's the same as saying X equals 75 and X equals X plus 100. So we could continue to use that if we want. Any questions on pointers up to this point? Okay. Now, let's see what we got going on here. What if I did something along the lines of int array? I'm going to declare an array, and I'm going to throw some values in my array, like 10, 15, 20. Now, this, can you see it? I'm sorry. This word, ARR, we're going to now go back to thinking about this being the memory address. ARR is the memory address of where I'm going to start storing values. And in this case, I'm going to store 3 values, all of size 4 bytes. So this memory address, I need to make sure I have 12 bytes available. The first 4 bytes gets the value 10, next 4, 15, the next one is 20. So when I think about it, I want to start to go with array points to a memory location of 4 bytes. Now, when we start looking at the subscripts, I'm going to think of it this way. That 0 is the same as 0 times 4 bytes, which puts me to there. When I go to find the next number, 15, I'm going to think of the subscript as 1. So I'm going to go to the memory address array, multiply the 1 times the 4 bytes to get to this location where the 15 is stored, and so on throughout the array. 4 bytes, and this would be subscript 2. So 2 says go to the memory address array and jump. So start to think of ARR as what we'd like to call the memory address. Now, if you take a look at code listing 9.5, you have something similar to this, and instead we now go and we write cout. Whoops. I was looking at the screen, not my paper. Cout asterisk, which we're dereferencing, ARR without any subscript beside it. So now I'm going to the memory address, I'm dereferencing it, and in this case, what would get displayed?
The memory address of the first element.
But not the memory address. If I just did ARR, it would give me the memory address. When I put the ampersand in front, I'm dereferencing it, so it's going to give me
The value.
the value 10. Yeah. So this
That's
would give
an
me,
asterisk, right? Not
that's
an
an
ampersand.
asterisk. Yeah, did I say ampersand? I apologize. An asterisk. It's an asterisk. Okay. What if I put an ampersand in front? What do you think would happen?
It's a memory address.
That gives you the memory address of
The memory
array.
address? It gives me the memory address of the memory
Array.
address. I don't think that's going to work,
Okay.
right? I'm thinking that's going to give me a syntax error, and that's not going to work.
It'll work. It'll just be a double indirection.
So that brings you back to where you started? Is that like the negative of a negative?
No, it would give you, like, if you wanted to set ARR later, you could do it through that.
Okay. I don't know that that's
Yeah.
something we want to do, but
Right. It's really, really strange, but it would compile.
okay. So let's go back to, thanks, Conrad. Let's go back to our cout, and we have our array here. And what if I did this? Cout asterisk array plus 1. What would get displayed?
Guessing the second number.
Which is what?
15.
15? Does anybody think it might be something else?
Would it be 11?
I'm hearing an 11. Why do you think it would be 11, Matt?
Would it be because we just said that asterisk array is the first entry in the array.
Right.
And then
Yep, it's
we're
not.
just adding 1 to that term.
Good. Excellent. So some of you who thought it was 15, you got a little bit dangerous and you were doing array plus 1 in parentheses. Okay. The plus 1 will do what for me? It will advance it over one unit, one actual int. So it's going to advance it 4 bytes. So if I say array plus 1, it's going to move it over to here. And then when I dereference it, it's going to give me the 15.
Yeah. I just did.
Okay. Good. Just something to check out. So
would
that we
that
don't
be the
mix them
same?
up. Go ahead.
Would that be the same if you did plus 2? It would go
Yep.
to 20.
Yep.
Okay.
Exactly. What if you did plus 3?
It would show whatever's currently stored at the address after the array.
Exactly. It would probably give us some kind of junk going on there. Okay. Another example of that was actually in code listing 9.6. So if you went back over and looked at all the code listings you typed in, hopefully where it didn't make sense will now make sense. I'm moving on to program 9.7, which is on page 507 if you're following in the book.
If there's nothing there, it puts a 0 there.
Correct.
Okay.
Correct. All right, moving on to program 9.7, it's on page 507. We start with the declaration of an array. That's kind of blurry, isn't it?
Yeah, a little bit.
Yeah. Y'all have your book, so maybe it'll be a little, if I had a better camera. But anyhow, it says double coins, and we declare an array of size 5, and we store a whole bunch of coins in it. The next row is double, a pointer to a double. We say asterisk double pointer. In this line right here, line 15, double pointer equals coins. Because remember, double pointer is a pointer to a double. Coins is the pointer to the beginning of the array, the memory location where it starts, and it stores doubles inside of it. So these two can work as the same thing. If you take a look at this first loop, we are printing out double pointer, which actually is my array pointer, using subscripts if we want. Remember a moment ago we did the dereference and then we added the 1 and so forth. We could go through. What this is saying is I can also use subscripts with a pointer. So I can say pointer subscript, just like array name subscript, because they're the same types of things.
So you don't have to like declare a pointer variable as an array. You can just use the subscript.
Right. You can say it's pointing to a double, and then we can traverse through by groups of doubles, which are 8 bytes.
Okay.
The other example down on the bottom is we're dereferencing coins, which is actually the array name, using it like we did a moment ago when we just had a pointer here. We're using an array name plus a certain number, dereferencing it to get the values. So this program really shows that the two are extremely interchangeable. Questions on 9.7? All right, so you had another program you typed in. It was program 9.9, and you went through, I'm actually going to use the book again instead of writing it out. You have an array that you're going through, and as you go through, you keep incrementing num pointer by using the plus plus. So instead of doing dereferencing of num pointer plus 1, we're actually able to increment num pointer, and when I increment it, it's now going to point 4 bytes to the right. It isn't int. Yeah, it's in it. So it's going to move us forward. So my pointer is now jumping from the start to the next 4 bytes, to the next 4 bytes, and so forth. It's just going to keep moving across. All right, good. When I'm done, where does my pointer point to? Well, it's going to point somewhere out here on the end as I went all the way through the loop. So when we take a look at this next loop, we get ready and we start decrementing from the pointer, which means I'm going to be here, and when I decrement, it's going to go back 4 bytes to the left, 4 bytes to the left, 4 bytes to the left. So I'm able to get back to the values in reverse. So way back when we talked about reversing an array, and we did the loop from 10 down to 0 or 9 down to 0, this is actually kind of another way if I can get my pointer out there to that last memory location. Cool? Questions?
This is just another way to do ascending, descending.
Yep. You're just, it's a way of moving the pointer over. Okay. So what
Mike,
All
Is mic cut out for everyone else?
Yep.
Yeah,
Faraday, mic's gone again.
All right, let me see if I can.
Oh, there you are.
there we go.
Now, can you hear me?
Yep.
Yes.
Yeah.
Okay, I just had to unplug my headphones and plug them back in. Sorry about that. All right, I'm looking on page 510, and I want to do 1 or 2 problems out of the book for 510. And the first one I have noted is 9.4, and it says, what's the output for the following program? You wouldn't mind taking a minute and walking through that?
What page was it?
Page 510, 510, number 4.
Program 9.4.
Yeah, yep. Walk through that and tell me what output you get.
Just adding 100, isn't it? The numbers.
Which one is this supposed to be? I think my book's numbered differently than your
Oh,
guys'.
you're thank
Yeah.
you. Thank you. I have the 8th edition, so I'm an edition off at home. I didn't realize I had the wrong book, the wrong edition. So I'm looking at the end of 9.5. Nicole, what did you say page it was?
It's page 518.
518.
Okay, thank you.
518.
What program number are we looking at?
At checkpoint on page 518.
9.4 is at the bottom.
Yeah, 9.4.
Okay.
I have X, I have Y, and I have Z.
It's adding 100 to each one, isn't it?
I don't know.
Looks like that's what it's doing.
Um,
Now coming out is 125, 150.
Not program 9.4, the checkpoint 9.4.
Oh, okay. Sorry.
It'd be 500, 300, and 350. Well, the first line would be 50, 60, and 70. And
Yeah.
then 300, 500, and 350.
Wouldn't it be 300, or sorry, 500, 300, and 140?
Yeah, that's, yeah.
Yeah. Times 2.
Oh yeah, 140. Yep, yep.
He's writing a lot of stuff. Did he stop talking? Oh, he went away.
Happen again.
And
And raw.
No, he's still here. His video's just gone.
Mm.
And
yeah.
And
Video.
we're back.
Are we all back?
I know.
yes.
I don't know why in your class my headphones keep cutting out.
Have you been talking this entire time?
Yeah.
Yeah, we can hear you.
All right. So we have 500, 300, and 140. Everybody's good with that.
Yeah.
If I said on a test, what's the difference between asterisk pointer and pointer? You would be able to give me an answer for that.
Yes.
Yes. This is dereferencing it. It's giving me the value. This is the memory address. Okay, the next one I want you to take a look at is 9.8. Start with letter A. Is that valid or invalid?
Valid.
I have a valid.
Unsure.
I have a not sure. Let's see what it is. I have int ivar. It's just
Should
a
be
variable,
valid.
just an integer variable. I have int. I'm declaring a pointer, and I'm going to give it a value. That value I give it has to be an address. And when I say the address of ivar, I'm good. I'm going with valid.
Someone else has joined in. I'm not sure who though.
Okay. I'll check it out later. The next one, valid or invalid? Int, Ivar, comma,
That's valid. That's
I would-
essentially the same thing as above.
I would guess valid, but I'm not entirely sure.
right. I would agree that it's valid, but I hope nobody ever uses this. I hope if anything, you use what's up above. But this is an int. This is an int. We're just declaring them int data types. C, float. F of R, that's a creative name.
It's like back man.
Int, asterisk pointer equals ampersand F of R. What do you think?
Not
It
valid.
would run, but
No.
you shouldn't.
Yeah, I'm going to say that it's invalid. It's not something that I would mess with.
Different data type.
Right, because of the different data type and the amounts and blocks of memory. Again, we would have to test this in Dev C++ to see whether it works or not. I'm going to say it doesn't. Hopefully nobody ever does that. I don't
No,
have
that
key in my book.
that would not. That does not compile.
What if this was a float and this was an int?
No, that wouldn't either.
That wouldn't compile either. I'm assuming you have a compiler open.
Yeah, those are actually the same size, so if it doesn't compile, then none of them will work.
Gotcha. That makes sense to me. The next one, int nums 50, I pointer equals nums.
Invalid.
Yeah, that should work.
That's
Yeah,
valid.
I'm thinking that should work because that's similar to what's up here.
Yeah.
It said
And
num50 just calling the same thing as a pointer variable.
say one more
That's
time.
declaring an array called nums of size 50.
Okay, it's not actually pointing to the size, like the
No.
location.
Well, the pointer is pointing to the start location.
Remember, we talked about nums being the address. So this is an address. This is a pointer. Its initial value is the address of the array.
You don't use the ampersand if it's an array.
Right. Very good. Did you get that, Christian?
I think so.
Okay. Because this is an array, I point right to this because it's a memory address. Up here, this was a primitive data type. So in order to get its memory address, I had to use the ampersand.
Okay.
It's same way if you're passing an array as a reference variable, you don't pass it with an ampersand, you just pass the name.
Correct. What about the last one?
Invalid.
Fix it.
Just reverse it.
Yeah. Yeah, if I move this one up, then we would get something that looks kind of valid.
It's just the first one again.
Yeah.
Yeah.
Upside down.
Okay. That doesn't seem like a lot, but it actually ends up being a lot. What's today? Thursday. On Tuesday, we're going to finish out chapter 9. But what I want you to do now is I want a program written. And again, I have the wrong edition of a book here, but I want you to go to, let's see, I have 544 because I changed it because of this book. Go to the programming challenges at the end of the chapter. Probably like 553, something along those lines.
I've got 550 as the start of the review questions tab.
Okay. So go over the
553 it started programming challenges.
Okay, so yeah, it's off by 9 pages from one year to the next. Okay, take a look at number 2. Number 2, test scores. Write a program that dynamically allocates an array large enough to hold a user-defined number of test scores. Once all the scores are entered, the array should be passed to a function that sorts them in ascending order. Another function should be called that calculates the average array. This program should display the sorted list of scores and averages, appropriate headings. All of that's good, right? So we're going to stop there. After we talk more about this on Tuesday, we're then going to come back to this program and we're going to talk about use pointer notation rather than arrays. Also, make sure you put in there input validation, have a check for that. So it's a nice little program to write using arrays, and then we're going to see how it's going to compare with pointers next time. So for now, I just want you to write it with arrays. Looks like we have plenty of time. I'm hoping everybody gets a chance to work on it. I'm going to put you in breakout rooms so that you work in pairs of, how many do we have? 4, 8, 12, 15. We're going to work in groups of 3. So I'm going to have 3 breakout rooms, and you're going to see in a minute how you get assigned to that. But for now, I'm going to stop the recording. And
As a question,
yeah,
are we accepting a user input of the number of scores they're allocating?
yes.
Okay.
I mean, it's up to you. If you want to assume that, make your array of size 20 and, let's just do test data for like 6 or 7 or 8 scores so that you get it up. Once again, make sure maybe that you want to, in your breakout room, come up with test data. Last class in their breakout rooms, they were using whiteboards. Like one student would get a whiteboard somewhere, and then that group used a whiteboard, and they come up with test data first, and then start writing your programs. So somebody's going to have to be sharing their screen. Other questions? Okay, give me a couple of seconds. I'm going to do breakout rooms after I stop recording.